So this is one way to categorize. We only discuss 3 types of categorizations. So the second method of categorization is called class-based, and the classless method. Why do we still specifically talk about class-based and classless? Because some of the network devices deployed in networks today still use some older versions of iOS. And there are some older devices, so although class-based and classless, newer devices can help us avoid this problem, but we still need to talk about this point. Now, many higher versions of iOS have already helped us avoid this issue, but we still need to discuss it. Because many company networks still use these old iOS. Then there are class-based dynamic routers, and classless dynamic routers. What is a class-based dynamic router? What is a classless dynamic router? In 2 sentences. So, a class-based dynamic router, when announcing routing entries. When announcing routing entries, does not carry the mask of the routing entry. So a classless dynamic router, when announcing routing entries, carries the mask of the routing entry. So these 2 protocols differ in whether we carry the mask when announcing routing entries. Why are there class-based dynamic routing protocols? Because in the early days we talked about our IPv4 addresses. At that time, were divided into 3 classes. When deployed in large networks, we use Class A addresses. In medium-sized networks, we use Class B addresses. In small networks, we use Class C addresses. In large networks, when deploying, what do we use? If the IPv4 address starts from 1 to 126, it is a Class A address. So these IPv4 addresses, we consistently consider their first 8 bits as network bits. For example, if we previously saw an address, it's 1.4. For example, 111.1.1.2, then it will not have any mask information, but when we see this address, it is a Class A address. I understand its first 8 bits are network bits. So this address belongs to what? 111.0.0.80.0-8. This network segment. I belong to this network segment, IPv4 address Class A, address based on the first 8 bits. Network bits. Class B address, no, SPIT 128, 191, first 16 bits, network bits, Class C, address, 192, 223, first 24 bits, network bits. So in the early days, our IPv4 addresses were planned in a classful way. So at that time, through routing iron projects, we didn't use masks now, right? We could directly know. This routing iron project, exactly how many bits are network bits, no need for masks. Then later, classmates, we talked about this address categorization method is not appropriate. One reason is its effective usable address space. Then it's only about 17 million effective usable address space network segment. So there are only about 17 million in total, which is clearly out of 4.3 billion addresses. You end up allocating only about 17 million segments. That's too few. So find a solution, right? So we created subnet masks, using masks to divide the address space, using masks to distinguish our subnets, distinguishing this network segment. This is the origin of our subnet masks, but we thought, since we are using classless dynamic routing protocols now, we use masks to deploy networks. Then you have class-based, right? Do networks without masks still have any use? Useless, right? So to this day, look at which company deploys networks. Not using masks. They all need masks. Look, the trio of address mask gateway. So class-based dynamic routers are all phased out. Which ones are phased out? Take it down, RIPv one has been phased out. This is why we need a version 2, IGRP has been phased out. Because it is class-based, right? So what do? The upgraded version remains. How is the upgraded version? The upgraded routing protocols. Like RIPv2, they can support simultaneously, class-based, so to speak. Can't say simultaneously supported. Initially, RIP could. But EGRP is not like that. That is to say, all these are what? Classless dynamic routers. Like OSPF, they are all classless dynamic routers, transmit entries with masks. This again is the difference between class-based and classless. Of course, the difference. Actually, our main purpose is to let everyone know what exactly is class-based for, because later we will talk about on older versions of iOS. If we run distance vector routing, some will encounter an automatic summarization problem, which is to adapt to our class-based networks. This is our class-based and classless categorization. Then the last type of categorization is called based on IGP-EGP categorization. Categorization IGP is actually easy to understand. Called running an IGP is called internal gateway routing protocol. EGP is called external gateway routing protocol, IGP and EGP. So how to define what is an internal gateway routing protocol? What is an external gateway routing protocol? We use a special term, running inside an AS dynamic routing protocol, called internal gateway routing protocol. Running between ASE's dynamic routing protocol, called external gateway routing protocol. What is AS? As full name is autonomous system. Classmates, you don't need to remember in English. English doesn't need to be remembered. So this AS actually is called what? Called AS number. Called AS number, then called autonomous system. Autonomous system. Autonomous system. So it's a set of numbers. The numbers use autonomous system. Number. To identify a set of devices. A set of devices in an area, or say a set of devices in a region. Collection classmates. So for example, we are inside a company. Inside a company. We have routers, we have switches, like firewalls, ASA, and say what AP like AP. So this set of equipment. We can use our AS number to identify. Like this is our Wolf Lab. So Wolf Lab, we can get an AS number, use this AS number. To identify belonging to this AS, belonging to such a numbered device. We all belong, all within the same area, using autonomous system numbers. To identify and distinguish our group of devices, we all live in Tumbling Garden Community Building 12, right? Living in the same AS box, using this AS number to distinguish and identify our group of devices. So, within this AS, the protocols we run between us are called internal gateway routing. Protocols, simply put, inside your company, inside your home. You can run dynamic routing protocols, running inside your home or company, internally running. That's our IGP, called Internal Gateway Routing Protocol. So typically, as we mentioned earlier, like RIPv1, RIPv2, IGRP, EIGRP, OSPF, ISIS. So this bunch all can be internal gateway routing protocols. So what is an external gateway routing protocol? What is it? Two pieces between devices in two areas. The protocol we need to run, for example, the right side is another AS. For example, we live in Tumbling Garden Community. We live in Building 13. Then on the right, we live in Building 14. We can use this AS number to identify our certain area of devices. Building 13, 1 AS. Building 14, 1 AS. We can use this AS number to identify our network of devices. So, between two autonomous systems, one is AS13, one is AS14. Between two autonomous systems, we run the dynamic routing protocol called External Gateway Routing Protocol, also known as EGP protocol, External Gateway Routing Protocol. So, its representative is called BGP, called Border Gateway Protocol, Boundary Gateway Routing Protocol. So far, we haven't talked about such protocols yet. Haven't finished talking about so many protocols. You might not know yet. No rush. Let's move on. When we get to talk about BGP later, we will be able to recognize why we need an external gateway routing protocol, why our internal gateway routing protocol can't satisfy the conditions we run between ASEs. So this is our about dynamic routing protocols. An introduction to classification. Next in our NP phase, we will start with distance vector routing protocols. Talking about our EIGRP after EIGRP is done, we will talk about our link state routing protocol, our OSPF, after discussing these two. Then ISIS we won't discuss in NP, because it uses the same algorithm as OSPF, so the working principle is roughly the same. You can refer in our online disk. The full set of notes placed in scientific research materials. Refer to those notes to complete experiments and practice. After we finish talking about EIGRP and OSPF, then we have a redistribution topic and a PBR topic. After discussing those two topics, we will talk about BGP. Then the routing protocols we commonly use, we will discuss them all. Okay, classmates, so about dynamic routing protocol classification. Are there any questions? Any questions, classmates? Any questions about the classification of dynamic routing protocols? Any questions? Including the way your routing protocols work. You can ask questions. If there are no questions, let's check what time it is. 8:03 p.m. We'll take a break in a while. After listening to so much theory, let's take a break. In a while with our These Theories, we take this theory into our study of EIGRP, the distance vector routing protocol. So, let's end the first half of the lecture here. Then we'll take a break until... We'll take a 15-minute break. We'll break until 8:18 p.m. Around 8:20 p.m. We'll be ready to start class. Take a 15-minute break. Then we can have some water. Use the restroom. Relax a bit. I suggest opening a window for ventilation. The rain should have stopped. Okay, then take a break. Regarding distance vector routing protocol, every dynamic routing protocol will have a database. Whether it's RIP, IGRP, OSPF, or BGP, they all have their own dynamic routing protocol database. We exchange between each other. The contents of the database. Only the distance vector. Routing protocol exchanges routes, while our link state exchanges routes. Exchanges information on the link. So every dynamic routing protocol will have a database. We'll demonstrate later. All right, we will demonstrate EIGRP later, okay? We'll demonstrate, we all will. We will talk about this. All right, then take a break. All right, take a break. Play some music.